So my flip chart right here says multiplying and dividing rational expressions. However, for right now, we're only going to worry about multiplying rational expressions. You're going to see that they're very, very close in nature. They're not that different at all, but one thing at a time. Okay. Basically, the rules that I want to establish with this, there's a lot of ways that you can multiply rational expressions. However, I think the simplest way that we can find is we want to do this. I want to factor completely. So if you look at my first example right here, there's one thing, another number, a third number, and a fourth number. So there's actually 4 different numbers that we're going to have right there, and we want to factor them all completely. 1. Number 2. Then we want to eliminate things that are the same, right? So we eliminate sameness, so to speak. And then number 3, multiply across the top, multiply across the bottom, and see what we have resulting in the end. So here's where we go. So right away, with these particular, the first 2 problems that we have, there's not any factoring that can really take place right here. We could expand this and call this 3 times x, and that would be fun, okay? But I hope that we don't need to anymore. Now we can just see things that line up and subtract away the exponents. So here's what we're going to do. In order to eliminate or in order to cancel things out, you can only do it if the 2 numbers are vertical or diagonal, okay? So in other words, I can cancel out numbers that line up this way and these 2 numbers right here, okay? I can cancel out these 2 numbers right here, and I can cancel out these 2 numbers right here. What you cannot cancel out when I multiply is a cross. I cannot cancel those out, and I cannot cancel those out, okay? So those are the basic rules that are established. So, long story short, let's get down to crossing some things out right here. The first thing that I would go to is I see a 3 right here. That is a coefficient, and I see a 3 right here as a coefficient. Guess what? 3 divided by 3 cancels out. On the top up here, I have x cubed, okay? And now watch this. I'm going to go down here. How many x's are here? Just 1. So guess what? That just went away, and the cubed right here just turned into a 2, okay? Because all I did was eliminate one of the x's. Now watch this. We can shoot off in this action right here. I've got x cubed over here, and I've got x to the 4th over here, right? So what happens here now is that they divide out, and now the x's up here are gone, and this 4 just became a 2. And now going here, I've got a 4 as a coefficient and an 8 as a coefficient. 8 divided by 4 is 2, so there's a big 2 up front there. X squared on the top, x squared on the bottom, they both cancel out. So of all the things that have canceled out right here, the only thing that we have left is 2. So the answer to that problem is 2, and that turns out real, real nice for us. I'm going to take the next one right here, and I'm going to expand it a little bit further, and maybe that'll make it a little bit easier for us to see. So let's do this. Here we go. On the top right here, if I was going to completely factor it, I would have 5x, x. This is just another way of doing the same thing to look at, okay? So if you can do a lot of this stuff in your head, then you don't need to write all this out. On the bottom right here, I have 3x. And now we're multiplying times the other side. To factor out 12, I would actually do this. 3 times 2 times 2. And then there's just 1x. And with the 10, now I have 5 times 2. But there's 5 x's. Okay, now again, recall, I can eliminate things that are up and down or vertical, and I can eliminate things that are diagonal. So first things first, here's a 5, there's a 5. Make them go away. Here's an x right here, there's an x right there. Make them go away. There's a 3 right here and a 3 right there. Make them go away. Here's an x right here and an x right there. Make them go away. A 2 and a 2. Is there anything else that I can eliminate? There is. I got one more x right here. So there's an x on top and one more x taken from the bottom. And now I don't have anything else left to eliminate. And I know this sounds or looks a little bit confusing to you, but if you'll keep things lined up the way that this is, it'll be a little bit easier for you to see. Across the top, what do we have left? Just a 2. And across the bottom, what do we have left? 1, 2, 3. X cubed. That's all that's left on the bottom. So again, it looks kind of confusing, but take your time, factor completely, eliminate sameness, multiply across the top and the bottom. So here come a few more examples. And we're going to get a little bit more difficult, obviously, as we progress, but hopefully not too much. So again, multiplying right here, rational expressions. So again, factor the top. Can I do anything to factor that? No, sir. So rewrite it. Factor the bottom. Can you do anything down here to factor this? Well, check it out, man. X squared plus 5x plus 4. With that right there, you should be on the side doing the diamond technique. And when you do the diamond technique, what we find is that we have x plus 4 times x plus 1 times. Can we factor this right here? We cannot. So it is x plus 4. And down on the bottom we have a 1. All right, so now it's step 2. Eliminate sameness. Again, what we got to keep in mind, guys, inside the parentheses right here, I have an x plus 4 and I have an x plus 1. You cannot get rid of one or the other. It's got to be everything inside the parentheses goes or nothing goes, okay? So with that said, let's look for some things that are the same. And right off the bat, I see that I have an x plus 4 here, and then diagonal, there's an x plus 4 there as well. Again, all or nothing. So x plus 4 entirely is now gone. The other things that could eliminate, 7x and x plus 1. Can't do it because I cannot separate the x plus the 1. They got to be the same. 7x over here times 1, nothing eliminates. So we're done eliminating things. And across the top we have 7x. And across the bottom we have x plus 1. Now remember, we're multiplying. So anything, everything in the parentheses, times 1, nothing changes. Okay, our last example right here. Put a little line in between. Again, multiplying rational expressions. So let's do this. We're going to factor everything completely. So on the top up here, 3x. There's no work to do, which is always good. Down here on the bottom, I got x squared minus 2x minus 24. Okay, so on the side again, you should be doing the diamond technique. And when you do that, you should end up with x minus 6 and x plus 4 times, on the top up here, let's factor that. I can't. So we have x minus 6. Now the bottom right here, again, only two numbers. So you're not going to be doing the diamond technique. Greatest common factor is what's got to come into play. So between a 6 and a 9, the greatest common factor there is 3. And now look at x squared and x. They both have a variable x. What's the lowest exponent? It's 1. So 3x is coming out. 6 divided by 3 is 2, and there's an x. 9 divided by 3 is 3, and those x's cancel out. So here we go. Step 2, eliminate sameness. Hey, check it out, man. There's a 3x there and a 3x there. Bye-bye. Those guys cancel out. Inside the parentheses right here, I have an x minus 6, and up here I have an x minus 6. Remember, it's all or nothing. Those guys cancel out. The only numbers that are left are x plus 4 and 2x plus 3, but they're next to each other. So even if they were the same, we cannot cancel those guys out. Nothing remains on the top, so I put a 1. And on the bottom, just leave it in factored form. X plus 4, 2x plus 3. And that's simplified as we can get with multiplication. All right, go get them.